In this presentation, we're going to look at how to do a proof using a truth table. Now, the first part of what we're going to look at here is P implies Q. Is that directly equivalent to not Q implies not P? So, by the way, this is the equivalent symbol. It's sort of like equals, basically. So that's equivalent. And importantly, this is implies. If then. Okay. By the way, I don't know at the time of making this presentation. I'm not quite sure what year it is. When I get to the YouTube video, or I'll update when I find out the right year. But for the meantime, I just got it's 2000 and XX. I don't know. So okay, so let's start off by making a truth table for the left-hand side, and then we'll do a truth table for the right-hand side. So truth table for the left-hand side. Let's get the pen out. Okay, so P and Q, and the start off by 0, 1, 0, 1. Just put in the set up your truth table in the usual way. Start from the right hand side and work left, and alternate between zeros and 1 every step here, and then every double 2 zeros, then 2 1s, and so on here. So P implies Q. Now, the best way to do this in this particular instance is actually just to remember how to do that truth table. Just for the purpose, I've explained how to in a previous presentation how to get them out, but how to rationalize it. But by the same token, for the time being, it's also a good idea to have it like this particular truth table learned off by heart. Now we're going to do it for the right hand side. And again, we set up our an equivalent truth table. You can actually sort of bunch them right beside each other, but they are actually intended to be different tables. So this is, let's do that one again. So not Q and not P. We don't have to start off with P and Q again. We can just use the values over there. So not Q is, let's look at this value here, 0, 1. So put in the opposite values here, 1, 0, 1, 0. Not P, well, we start off with, there's a 0 over here. So that'll be equivalent to a 1. And a 1 here. 0 and 0. So, not P and not Q. Actually, just as sort of remark I just sort of said earlier, you can actually sort of combine them, but just sort of show that you're doing two different operations. So actually, probably a double line down the middle, just to show that it's a continuation in some respects, and that the columns or the rows are equivalent to each other. So making them separate, two separate tables is probably overstating it a bit, but just make it obvious that you're doing two different operations. Anyway, going back to what I was saying now, not P and not Q. So what we're going to do is use the first table here to populate the second table, or the first half to populate the second half. So 1 and 1 down here, that we know that to give that a 1. 1 and 0, 1 and 0. Here we know to give that a 0. 0 and 0 we know to give that a 1. And 0 and 1 we know that to give that a 1. You might actually sort of see that, like, for the most part, in the middle of these rows here are almost identical to the middle rows over there. It's actually the top and bottom row have got swapped, as in say those have been swapped around from the first side. That's just a sort of digression. Anyway, the last part is to state explicitly that this column here is directly the same, is directly similar is it exact same as this here? So that's minus q. Let me rub that out. Minus not q implies not p. Okay. And again, that was similar. So these two are the exact same. So just make a little statement about that in your question. Alright, that's a proof by truth table.